Good afternoon and welcome to this session on the discussion with regards to how you will be able to fill up the laboratory exercise number 5. Okay, so the title of our laboratory activity is Basic BJT Amplifier Circuit. As we have discussed, the next na semiconductor device that we will be focusing is the bipolar junction transistor. And then we will be, okay, itong laboratory activity na to will be focusing on one functionality of our BJT, which is when it works as an amplifier. So before we move on to discussing yung ating laboratory activity, una muna is let's first define ano ba tong ibig sabihin ng amplifier. So basically, pag sinabi nating amplify, merong part dito class na ini-increase natin yung intensity. So from a small na value or small amount, pinapalaki natin. So an example of this is when we are singing in a karaoke, no? Na yung boses natin is mahina lang naman, okay, maririnig lang tayo ng ating kausap, pero once pumasok na siya sa amplifier, yung boses natin is actually becomes, okay, pwede natin madungog sa pikas na kanto. So that's basically yung amplifying effect. Okay, so from a small amount to a larger amount. So again, I'll leave you with the reading of the details of this particular laboratory activity. Okay, on this introduction, we proceed directly, class, to this equation. Okay, that IE is equal to IB plus IC. That the emitter current is equal to the base current plus the collector current. Okay, so we have IE, okay, emitter current, base current, and then the collector current na IC. Okay? So itong equation na to is actually related to our discussion previously na yung emitter is actually the most heavily doped among the three parts of our transistor. Kaya naman, it is yung kuryente, ito yung pinaka-largest na current among the currents in our BJT. Now, yung lightly doped na base, yun yung pinakamababa naman as we will be observing later on. Okay? So, IB plus IC is the IE. So, basically, kung titingnan natin itong ating transistor, okay, we have this base. So, papasok yung kuryente dito. We have also the collector, papasok din yung kuryente dyan. Then, we have this arrow na palabas by virtue of Kirchhoff's current law. Okay? Current entering, IB plus IC is equal to current leaving, which is our IE. Now, moving on. Aside from that relationship between the three currents, okay, we also have this one. Okay, the collector current is the product. So pag sinabing product, it's actually a result of multiplication. So product siya ng transistor amplification factor or the beta value times the base current. Kaya naman, mapansin nyo dito, okay, IE equals IB equals IB. Pero yung IC, napalitan na ng beta IB. Sa product ng transistor amplification factor and the base current. Okay, and further simplifying this equation, ilabas lang natin yung IB or the base current, then 1 plus beta, okay, quantity 1 plus beta times IB, that will be the value of our IE. So, take note of these equations. Gagamitin natin to mamaya. The next, so this is our first na biasing, okay, yung biasing a transistor. So we have our VCC or the supply voltage connected to our collector. Okay. So this VCC is connected to the base resistor RB, collector resistor RC, and our transistor. Meron tayong mga equations dito, class. Now, sabi dito, to solve for IB, the base current, okay, we need to create a loop in the input side. So yung input side dito will be this one, VCC, then RB, then flowing through this base emitter diode, yung VBE, then going to the ground. Again, that's VCC, then flowing pababa. Kaya naman yung equation dito will be VCC minus the voltage drop since this is a resistor, Okay, so yung current na dumaan sa resistor times the resistance, that will be the voltage. Okay? So VCC minus that voltage minus the VBE, this diode over here, the base emitter na diode. So that is actually 0.7 kung silicon yung ating transistor. So kung gusto nating ma-solve yung IB, so ito, ilipat natin sa kabila, magiging positive. Then we divide both sides by the RB. O kaya naman, ito yung ating magiging equation. Okay, VCC minus VBE, ilipat natin to sa kabila, IBRB, divide both sides by RB, makukuha natin yung base current. Then to solve for VCE, yung collector emitter na voltage, the voltage between the collector and the emitter. Pag naglagay tayo ng voltmeter dito, we need to consider the output section naman. So VCC, collector, then the VCE, then to the ground. Ito naman yan. Kaya yung equation niya, titingnan natin dito, we'll have VCC minus ICRC, the voltage drop across this resistor, minus the VCE, the voltage drop across the collector to emitter, is equal to 0. Gusto natin ma-solve yung VCE, lipat natin sa kabila, magiging positive, then VCE is equal to VCC times ICRC. Again, take note of these highlighted equations. Magagamit natin to mamaya. Now for the materials and equipment, so very important dito class will be the 9-volt battery or yung ating DC power source, yung transistor natin na BC547, and then the resistors. Okay? Yung iba, yung battery clip connector, breadboard, multimeter, di na tayo gagamit niyan. Ang gagawin natin is simulation. So here we have our circuit. So instead of connecting through our breadboard, ang gagawin natin is isa-simulate natin. Hindi natin yan gagawin. So connect the circuit below. You have the VCC 9 volts, 240K na base resistor, 1K na collector resistor, and we have our transistor. Okay? First of all, before continuing, okay, search muna natin yung beta value or the transistor amplification factor ng BC547. 1. So here we have BC547 transistor has a gain value of 110 to 800. In this case, class, okay, ang gagamitin natin will be 110 in a beta value. This one. So this is our circuit. Punta tayo ngayon dun sa ating simulation. Okay, so we create a new design. This one. This is the ground. And then we interconnect our supply. Sabi dun kanina sa materials, this will be 9 volts. Click natin yan. Click natin ito. And then 9 volts. Right, then resistors. RB is 240 kilo ohms. Okay. Then we have RC. This one. And then our transistor na NPN. Okay, yung BC547. Okay, interconnect this one. This is now our circuit. The 9-volt battery, the base resistor, the collector resistor, and our transistor. Now, again, we change the beta value. So, click natin yan. Click natin to. And then, forward beta, instead na 100, gawin nating 110. Ayan, so we already changed the beta value to 110. So, now, this circuit is actually the same with this schematic diagram. Now, the first one, ang first na concern natin dito is to solve the values of these four quantities. Yung IB, IC, IE, and VCE. Again, the beta value, yung value niyan will be, okay, the value nito is 110. Okay, na to solve for the value of IB, IC, IE, and VCE, andun na sa ibabaw. Okay, we have the formula for VCE, we have the formula for IB, we have the formula for IE. This one, beta plus 1, IB. Meaning, pag na-solve natin yung base current, we have already the beta value plus 1, multiply natin sa IB, we will be able to calculate the IE. So, yung ating collector current naman is the product of transistor, amplification factor, and base current. So, ito beta IB. So, when we multiply the beta value times the base current, makukuha naman natin yung value ng collector current. So, yan lang yung force number 2. Okay? So, very important dito, class, i-compare natin yung value ng IB, value ng IC, at value ng IE. The next is, dito sa baba, using your multimeter, dito sa baba, using your multimeter, measure IB, IC, IE, and VCE. So, this one, since hindi tayo mag-a-actual, we will be simulating. Hindi na ito yung gagawin natin. Instead, punta tayo dun sa ating simulation and then we will measure IB, IC, IE, and VCE. Okay? Para magawa natin yan, mag-i-insert tayo dito ng mga measuring devices. Itong ammeter. Okay, so insert tayo dito sa base. Cut natin yan. We insert the ammeter here. And then we have here for the collector current. So cut natin yan. Then we insert our ammeter here. And then dito naman sa ilalim, okay, for the cut natin yan. And then we insert our ammeter for the emitter current. Very important na mag-flow yung ating kuryente sa ammeter so that we will be able to measure current. Then next is the VCE. So, kung napansin nyo, class, we connected the ammeter in series. So, ito yung ating resistor, siniris natin yung ammeter. Well, for the voltmeter, we will be connecting this in parallel. So, ito yung collector. So, collect natin yan. Then, connect natin dito sa emitter naman, yung voltmeter. Then, this one, connect natin sa ground. So, this is now our circuit with along with the measuring devices ng mga ammeter and voltmeter. I will try to run the simulation. Ayan, we have our base current here, 34.3 microamperes. We have our collector current, 3.78 milliamperes. And we have our IE, or the emitter current, 3.81 milliamperes. Now, try to compare this one, itong mga values na nakuha natin dito. Try to compare this one with the ones that you have solved dun sa ibabaw. Dun sa question number 2. And then for VCE, we have 5.22 volts. This one. Once you already did this, okay, try to get a screenshot para as sort of proof na you were able to design, wire, and test this particular circuit. Patay ng screenshot nito and then isama natin dun sa ipapasa natin na laboratory activity. Now, by the way, class, let me just emphasize na you have to do this. Okay? You have to wire this one using your app, okay? Yung every circuit app ninyo dyan. So, kailangan gawin nyo to. Okay? So, that sort of, yun na yung inyong proof na you are able to design, okay, wire and test. So yung sa design, we change the beta value, so that's part of the designing process. From 100, ginawa nating 110 the resistances. From 1K, ginawa nating 240 yung base resistor. And then the connections, okay? Na yung ammeter connected in series, yung voltmeter connected in parallel. These are actually part of the designing process. Then we interconnect the devices. That is already the wiring. Then once we simulate, that's part of the testing. So again, one of the intent of this laboratory activity is for you to design, wire, and test the BJT amplifier circuit. So going back, so after you have already simulated, so you record the values of IB, IC, IE, and VCE here. Sulat nyo dito. And then answer this guide question. So how does transistor act as an amplifier? So saan dun nangyari yung amplification? So you try to answer this question. As well as yung pangalawa, discuss ano ba yung ibig sabihin ng amplification gain or yung beta or yung binanggit natin kanina na transistor amplification factor. Ano ba yung ibig sabihin yan? So discuss, pwede niyong i-research ito. Okay? Discuss the amplification gain na beta. So that ends the discussion for this laboratory activity. If you have any questions, you may raise them sa ating GC. Or kung medyo alanganin kayo class, you can send a PM, okay, for us to discuss your question.